Okay, now we're going to do the velocity versus time graph. In many ways, this is easier than the position versus time graph for this particular problem because if you look at what I wrote down here for the position graph, we are actually given the velocity. So standing still would be 0 velocity. Running, it's a -3 meters per second because our speed is 3 meters per second, but we're going in the negative x direction. Walking is -1. Again, we're walking in the negative x direction. And finally, running is +3. So what I'm going to do is the same thing we did before. I'm going to go ahead and draw an axis. And I can see by looking at these velocities, this is v equals 0, this is v equals 0, that I'm going to need to go between 3 and -3. So that I can handle. 3, 2, 1, 0, -1, -2, -3. And this is in meters per second. And then the time, again, I'm going to do 10 seconds. So this would be 10. This is 5. And you see I'm getting better at this. I can do 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4. 6. Okay, so between 0 and 1 second, the velocity is 0. So I'm going to go ahead and put that in. And between 1 and 4 seconds, the velocity is -3. So if I go on down here, okay, between 1 and 4, it's -3. And then between 4 and 7, it's -1. And between 7 and 9, it's plus, so I can draw this, it's +3. Now, in reality, you don't just instantly start running or instantly go from running to walking or instantly switch directions. So in the solution and in the real world, these won't be completely flat like this. They'll be curved a little. Okay? And the curve a little is just it takes time to change speed and direction. Okay. And if you were to do this with the motion sensor, you would see the same thing. So this is the velocity versus time, and here it's easier to read off what you're doing when I forgot 0 at the end. You're standing still here, running in the negative x direction, walking in the negative x direction, and running in the positive x direction before stopping again. Okay, so that's velocity.